Hi everyone, it's Miss H, and today we're going to be looking at balancing reactions. Before we get into actually balancing reactions, we need to know a few key terms. So the first is that a chemical reaction is what happens when one or more substances undergoes a chemical change to produce one or more new substances. So what this means is that what I start with and what I end with will not be the same thing, but the same components will be on both sides. The reactants are the substances that we start with in the chemical change, so they will be typically listed on the left side of the arrow. The products are the end result of the chemical change, so they are the thing that gets created during the chemical change. They will typically be on the right side of the arrow. The arrow that is in the equation is typically read as yields, but we can think of that as creates, makes, generates, becomes, any of those. What we're saying is that this reactant combination yields this product combination, or this reactant combination creates, generates, makes, becomes this product combination. When we are balancing chemical reactions, what we are trying to do is make sure that the reaction is observing the law of conservation of mass. The law of conservation of mass says that matter cannot be created or destroyed, which means that I have to have the same number of each element on each side of the reaction. The large numbers in the front are called coefficients. These are the only things that we change in the reaction. If we try to change anything else in the reaction, we're actually changing the compounds we're working with. They tell you how many copies of each element or compound you have in that reaction. And again, they're the only thing that we're going to be able to change. Let's take a look at some examples. Here we have CH4 plus O2 yields CO2 plus H2O. So the first thing that I like to do is to separate my two sides. So this side is my reactants, and this side is my products. The next thing I'm going to do is I'm going to list the elements that are on each side. I like to list them in the same order on each side, but it doesn't matter if they are as long as you can easily compare them. Next, I'm going to count and see how many do I start with. So I start with 1 carbon on the reactant side, 4 hydrogen, and 2 oxygen. On the product side, I start with 1 carbon, 2 hydrogen, and then I have 2 oxygen here in the CO2, and I have 1 oxygen here in the O2, so 2 plus 1 gives me 3. So I'm starting with 3 oxygens on that side. The next thing I'm going to do is I'm going to start adding coefficients to tell me to change how many of it I have to try to get things balanced out. So my carbons are currently balanced. I'm not going to do anything to change those, but instead what I'm going to do is I'm going to look at the hydrogens. So right now I have 4 hydrogens on the reactant side, and I want to end up with 4 hydrogens on the product side. Whatever I put in the coefficient space, I'm going to multiply by the subscript. So in order to get 4 hydrogens on this side, I'm going to put a 2 in the coefficient because 2 times 2 is 4. So 2 times 2 is 4, so now my hydrogens will be balanced. Just like in math, you can think of this as the coefficient on the outside and then this being in parentheses, and you are distributing to it. So now I have 2 oxygens in the CO2, and I have 2 oxygens in the H2O because I have 2 copies of H2O. So now I have 2 plus 2, which is 4. The next step is going to be trying to get my oxygens balanced out. So when I go to get my oxygens balanced out, I'm then going to look at the O2. So if I put a 2 in front of the O2, then it becomes 4 because 2 times 2 is 4. And then I am done with balancing that out. So now I'm technically finished. I don't actually need to do anything else. However, in order to make sure that it's understood that you didn't just forget to finish the problem and that you actually knew that it was balanced, we like to put 1s in any of the remaining blanks. Again, just because it helps us to see that, yes, I knew I finished and I didn't leave anything undone. And now we're going to take a look at this second example here. Again, I'm going to separate my reactants from my products, and I'm going to show this one a slightly different way so that those of you who like to show things in a different way, that the way I just showed you doesn't work very well, have a different way to do this. So this time I'm going to say that my H's are going to be green, and my O's are going to be blue. So I am representing my molecules by just drawing them out instead of listing them the way that I did before. So the first step I'm going to do now is, if I count, I can see that my oxygens are not balanced, but my hydrogens are. And it's not necessarily easy to see what I'm going to have to do to balance this out. But if we look at the reactant side, that means we have to have an even number of oxygens because 2 can only be even. So the first thing I'm going to do is I'm going to put a 2 in front of the H2O as a way to make it so that I have an even number of oxygens on this side. So what this says is that I now have 2 copies of H2O. So now this shows that I have 2 copies. This right here says I have 2 copies of H2O, and this is saying that I have 2 copies of H2O. So now I have an even number of oxygens on both sides. So now I can mess with this in order to make it into the next number. So I'm going to look at this at the reactant side now, and I need to add a 2 in front of the H2O. Oh, that's not a good color. So I'm going to add a 2 in front of the H2O2. So now I'm going to have 2 copies of H2O2. So I'm going to make my second copy down here. And so if I look at this, if I count up down here, I have 4 green H's, and over here I have 4 green H's, and over here I have 4 yellow blues, and over here I have 4, what did I say? 4 blue O's, and over here I have 4 blue O's. And so that means that I am finished. And again, I'm just going to put a 1 in this last blank to help make sure that I understand that I did actually finish the problem and I didn't just forget that I needed to put something there. So again, there's lots of different ways that you can do this depending on what works best for you. Some people are more visual and some people like the numbers better. It's up to you which one you think works best for you. So if we take a look at another example here, I'm going to separate my 2 sides. Again, this is my reactants and this is my products. I can do the same thing I did last time where I have my Na and my O2. And then over on this side, I have my NaO, my Na2O. So again, I'm going to start out by trying to balance out what is on the product side in this case. So I'm going to put a 2 in front, which now means that I have 2 copies of Na2O. And so now I can see that I have my O's are balanced out because I have 2 O's on this side and I have 2 O's on this side. So my O's are now balanced out, so now I need to balance out my NAs. So I need to have 4 copies of Na. On the reactant side. And so again, now I can count that this 4 here, that tells me that I have 4 NAs. And with this 2 here, I have 4 NAs, and I have 2 O's, and I have 2 O's. So then I can put a 1 in my last blank to show that I have completed this one. All right. This time I'm going to go back to the way that I showed it the first time. Again, it's up to you which way you like it the best. That's why I'm just showing you different methods so you can pick which one works best for you. On this one I have aluminum, iron, and nitrogen. Aluminum, iron, oops, forgot the E over there, and nitrogen. I started with 1 aluminum, 3 irons, and 2 nitrogens. and I ended with 1 aluminum, 1 iron, and 1 nitrogen. So my first step is going to be to figure out what I need to balance out. I can either start with the Fe or the N, it doesn't matter. I'm going to go ahead and start with the Fe and put that 3 there, which will change that one to a 3. Now I'm going to go to my N's, so I'm going to put a 2 here. That 2 is going to go to the Al and make it into a 2, and it's going to go to the N and make it into a 2 as well. And then my last one is going to be over here. I'm going to need to put a 2 in front of the Al to make that into a 2. And then everything else is balanced, so I can put a 1 in the last one to show that I'm finished. I'm going to go ahead and skip that one just because I want to make sure we have enough time to get to this one right here. So this one is a little bit more complex looking. And one thing I'm going to do with this one first is that I'm going to put parentheses around all of my polyatomic ions because I can treat them as a single thing. So the OH gets parentheses, the SO4 gets parentheses, the SO4 gets parentheses, and then, oh, I don't have an OH on the product side right now. But I can rewrite H2O as HOH, and then I have my OH on the product side. So now I can separate my two sides, and I have Na, OH, H, and SO4. Na, OH, H, and SO4. Now it's important to make sure you put your parentheses in the right place so that you include the subscript inside of it. So if I do my counts now, I have 1 sodium, 1 hydroxide, 2 hydrogens, and 1 sulfate. I have 2 sodiums, 1 hydroxide, 1 hydrogen, and 1 sulfate. So the first thing I'm going to do is try to balance out those sodiums. So that puts that 2 there. That makes my sodium into a 2, and it makes my hydroxide into a 2. Then I'm going to go over to the other side, and I'm going to try to balance out my hydroxides now. So I put the 2 there. That makes the hydrogen into a 2, and it makes the hydroxide into a 2. And now everything is balanced, and I can put 1s in the remaining slots. Okay. This last example here shows you the same idea where you have your polyatomic ions. You can choose to separate your polyatomic ions into their individual pieces, and if you have a more complex problem where you don't see the same polyatomic ion on both sides, you will have to do that. However, in this class, you're probably not going to need to do that because this, again, is a very basic intro-level physical science class. I hope that this has helped you better understand how to balance reactions, and I hope that you have a great day.